Have you ever wanted to be in two places at once? It's not something we can do, but atoms can. How is this possible? Well, atoms are the building blocks that make up everything we can see in the universe. But when we look closely at atoms, they exhibit some pretty mysterious behaviors that we don't see at large scales. Sometimes atoms act like solid particles, or a lot like billiard balls, bouncing off each other and other objects. But sometimes atoms act like waves, just like waves on the ocean. So a single atom can travel through two passages at the same time. That's how an atom can be in two places at once. And when these atoms interact, they can scatter off each other, pass through each other completely, or combine. The study of these behaviors is called quantum science. This field has changed humanity's understanding of the very nature of the physical world. It has also led to the development of all kinds of technologies, including cell phones, computers, MRI machines, and even GPS. But Earth's gravity makes it tough to study these little atoms for very long. So, NASA built a quantum science laboratory in space. They named it the Cold Atom Lab. It operates inside the International Space Station, but it's run remotely by scientists back on Earth at NASA's Jet Propulsion Laboratory in Southern California. Inside the Cold Atom Lab, atoms are cooled to less than 1/1000th of a degree above absolute zero. That's colder than the coldest matter ever found in the natural universe. Because cold atoms are almost motionless, it's easier to look closely at how they behave. And did you know a whole bunch of cold atoms can also start to behave like one big quantum wave? This is called a Bose-Einstein condensate. It is a fifth state of matter, distinct from solids, liquids, gases, or plasmas. It makes quantum behaviors bigger and easier to study. Without Earth's gravity getting in the way, scientists can study atoms longer and open up new avenues of quantum exploration. NASA's Cold Atom Lab is the first quantum science facility in Earth's orbit, and it's helping us answer new questions about the quantum nature of the world around us. What we learn from the Cold Atom Lab could one day be used to study the composition of other planets and moons from orbit. They could also improve space navigation or help us understand cosmic mysteries like dark matter and dark energy. Who knows what we may discover next? Quantum science could change our understanding of the universe, one cold atom at a time.